premises-based infrastructure, for example, creating your virtual machines on-prem. Terraform can also be used to create other PaaS services. For example, Terraform can be used to build pipelines on GitHub. Terraform has multiple providers, and more providers are being added as we speak. And this enables Terraform to provision infrastructure as well as do a lot of interesting stuff. Anything with an API can be transformed into a Terraform provider, which Terraform would then allow you to play against. But primarily, we're looking at Terraform in terms of saying, how does Terraform enable us to work with infrastructure as code? In the Terraform world, infrastructure components are looked at as resources. For example, a virtual network is a resource, a VPC is a resource, a subnet is a resource. And if you really look at it, a resource goes through a complete life cycle. A resource needs to be provisioned, a resource needs to be created, taken care of, and then the resource goes through a configuration management process where you configure the resource to your needs. Then the resource has to be monitored, its performance has to be monitored, its uptime has to be monitored. Then the resource has to go through a governance and compliance lifecycle, and as part of the overall process, there is also a resource optimization to make sure that the resource is optimized for its needs. Sometimes utilization plays a key role, and this, in a nutshell, is the overall resource lifecycle. And there is also a resource deprovisioning at the end, and that's what a complete resource lifecycle looks like. Again, IAC isn't new. While IAC is a buzzword now, IAC isn't new. Previously, I've used Chef and Puppet right from the time we've had on-prem networks, before even cloud providers. We used to use languages like Chef, Puppet, Ansible to enable us to manage infrastructure as code. And these still exist, and these still play a key role in managing infrastructure. In fact, we have a large footprint of Ansible within our own organization. But with cloud providers, for example, AWS has its own CloudFormation templates. AWS has also got the AWS CLI. Similarly, Azure has its own Azure CLI. Azure also has got the Azure Resource Manager. There has been an explosion in all the various languages and formats which enable you to manage infrastructure. And there has been work done to sort of say, how can we simplify managing multi-cloud environments or hybrid cloud environments? And Terraform has been pretty successful in being able to sort of provide a unified interface across to use multiple resource providers. And having done that, Terraform in some ways has been pretty successful in doing that. I sort of looked at the a Google trend map on how Terraform has been trending. And if you really look at it, there's been pretty big growth in how Terraform, in interest in Terraform across. Terraform has really picked up in the last, I would say, 6 to 7 months, with a huge amount of interest based on the providers that Terraform has been able to onboard onto its platform. Another one that's really interesting, and it's also gathering a lot of speed, is Pulumi. I'm not aware of how many of you folks have even checked out Pulumi. Pulumi is interesting because, unlike Terraform, it allows you to use languages that you're comfortable with. For example, you can use Pulumi with C# to create a script to stand up infrastructure. So that's the basis on which I'm starting this. I'm not going a lot more into detail in terms of what is infrastructure as code, what is DevOps, how is DevOps, what's the DevOps process. So this is primarily a Terraform 101 course. I'm not getting too deep into IAC concepts or into the DevOps concepts. It's primarily about using Terraform and the HashiCorp configuration language to get started. Any questions or anything else that anybody else wants to add right now? Okay. So if there's no questions, I assume you're good to go. Um, can you guys hear me?
Yeah.
It's too quiet. It's strange to
Yep.
be talking.
Yep.
You're blowing our
Okay.
minds, Pradeep. You're blowing our minds with this in awe.
Hopefully for the right reasons.
Yeah, no,
Okay,
it's good. No, I think it's a new for a lot of us. So yeah, we're all here.
sure. Terraform is a declarative provisioning tool for ISE. So to use the term declarative, I just want to get into a bit more of what's declarative versus imperative. So let's look at imperative. So imperative is primarily around saying what exactly you want your source code to do. For example, on Ansible or in Chef, if you want to stand up a virtual machine, you would basically issue a bunch of instructions, which would primarily look like create a network, and this is how you create a network, and you would fire 5 to 6 commands to create a virtual network. Then you would use it and say, hey, create a subnet, and you would fire 5 or 6 commands on your command line to create a subnet. Then you would say, okay, I need to create a virtual IP address. Then I would need to create a virtual network interface card. So you would fire a bunch of commands which exactly tell what the underlying infrastructure has to do to be able to create those infrastructure components. That is imperative programming, wherein you're not only telling what you need, you're also telling how to get it done. Whereas in the declarative provisioning world, you do not tell how to do something, but rather you say, what do you need? In the declarative world, you basically say, hey, I need a virtual machine. And then you know that because you need a virtual machine, you would need it to stand on a network. So you would say, hey, I need a virtual network. And then you would know that, okay, to create a virtual network, you would need subnets, you would need IP addresses. So you basically tell the underlying infrastructure, hey, create a virtual network for me, create a virtual machine for me, create a subnet for me, and it figures out what are the commands and instructions it has to pass to the underlying layer to get that done. So the primary difference between declarative and imperative is in imperative, you specify what you need and you specify how to get it done. Whereas in the declarative world, you only specify what you need and the underlying platform figures out how to get it done for you. Terraform is a declarative provisioning tool. You tell Terraform what you need, and Terraform works with your underlying infrastructure provider. Let it be a cloud-based provider, let it be an on-prem provider, to figure out how to get it done for you. Terraform is from HashiCorp. It's an open source tool. So Terraform uses its own DSL. It's called HashiCorp configuration language. It looks a lot like JSON, behaves a lot like JSON, but it's still not exactly JSON. Terraform can also use JSON, but in most of the situations, I've seen folks use primarily HCL. It's very rare that you would see somebody using JSON as part of creating Terraform, as part of a Terraform project. Uh, the other reason why Terraform is pretty popular is Terraform allows you to create infrastructure in a very safe and predictable manner. Um, Terraform is a life cycle which involves your ability to create an infrastructure and not only declaratively say what you need, but it also allows you to say, hey, if I create this infrastructure, can you do a dry run to show me how will this infrastructure be stood up? Can you create a plan and show to me how this infrastructure would really be created even before the infrastructure is actually created? There have been issues in the past wherein people have accidentally tripped up destroyed piece of infrastructure, especially when using software-defined networks and software-defined components. It's very easy to trip up and bring down whole data centers. Terraform sort of holds your hands through that by having a workflow. We will go more into the workflow later in the session. Terraform is a plan, apply, destroy, validate, plan, apply, destroy process wherein you can validate what you're trying to do. You can generate a plan of the infrastructure that you're trying to generate. And if you're okay with the plan, then you would say, hey, apply this infrastructure, and then it would go create that infrastructure. Terraform also uses graph here to sort of say how would this infrastructure be created. Terraform builds a graph. Terraform can be declarative because Terraform builds a graph of all the various dependencies for standing up all the various pieces of infrastructure. For example, if you want to stand up a virtual machine, Terraform knows that, okay, you would need a VNet in Azure. Terraform knows you would need a subnet. Terraform knows that you need an IP address. Terraform knows you need a network interface card. And Terraform also knows and understands how all these various net components are related to each other. and Terraform can build a graph which will now allow you to stitch these things together. And that allows Terraform to figure out the various dependencies and allows it to declaratively provision various pieces of infrastructure for you. The other benefit of Terraform is that it's a multi-purpose composition tool. As I said right at the beginning, Terraform allows you to create infrastructure on IaaS, PaaS, and SaaS providers. So you can basically use Terraform to compose IaaS infrastructures in terms of standing up bare metal VMs, um, um, uh, telephony components, and a bunch of stuff. Terraform can also be used to stand up PaaS components. For example, let's assume you want to stand up an Azure App Service or an AWS EC2 instance or an AWS EBS instance. Terraform can be used to do that. Terraform can also be used to stand up SaaS providers. For example, if you want to stand up Salesforce as an example, Terraform is a Salesforce provider, and you can even stand up something like Salesforce out of Terraform. So Terraform allows you to do multiple tiers of composition. Terraform has also got a plugin-based architecture. Terraform has got a huge number of plugin providers. I will on Terraform's website. You can see the number of providers it has. It has 100. I know it has a pretty huge number of providers. And it's also open source, primarily being moderated by HashiCorp DAO, which is a spin-off from HashiCorp, which is primarily looking after their open source projects. Um, why Terraform? So before Terraform, we had Chef, Puppet, Ansible, and a lot of other IAC tools. Uh, Most of these tools were created primarily from a configuration management perspective. These tools started the journey much before the cloud exploded, and they were primarily built for on-prem infrastructure. I've personally used these to stand up virtual machines, configure virtual machines, and manage the lifecycle of virtual machines and bare metal servers, right? So these are used for configuration management and not resource orchestration. When we talk about resource orchestration, I'm talking about the initial lifecycle that I told you about. It's about resource provisioning all the way up to managing the resource, going through its life cycle and deprovisioning it. Whereas Chef and Puppet are primarily used for configuring resources. For example, you want to configure a VM, that's what Chef and Puppet are primarily, that's where their strengths lie. Chef and they have a combination of both declarative and imperative approaches. Puppet and Salt are primarily declarative in nature, whereas Ansible and Chef are imperative. There are Ansible recipes and Ansible playbooks out there, which are primarily imperative, and there are reams and reams of code which basically have a lot of instructions on how to stand up things. Um, Again, they all use different languages. Chef is primarily based out of Ruby. Puppet uses JSON. Ansible is YAML. And so you need to know a lot of different tool sets and toolkits to be able to use these tools. Any questions so far? Okay, I'll move forward. So what's Terraform? How does Terraform's architecture look like? So Terraform is a core component. These core components are primarily used for um, looking at your source code and compiling it and building a map. The core can understand your .tf files, run through your code, and build a dependency graph. The core then communicates with providers and provisioners, which is what is a plugin model of Terraform. So these providers could be built by any infrastructure provider. So there are providers for Azure, as I said initially, there are providers for Azure, AWS, Datadog, DigitalOcean, and a huge number of infrastructure providers out there. There are also components called provisioners, which can then be used to configure further infrastructure components that are primarily provided by these providers. And the plugin model is pretty extensible. It's open source, and any one of us can even go ahead and build our own plugin if needed. These plugins then use a client library to talk to upstream APIs. So, for example, the Azure RM provider for Terraform talks to the Azure APIs. So you program against the Azure RM provider, but on the back end, it talks to the Azure APIs. Similarly, you program against the AWS provider, and it talks to the AWS upstream APIs. And that's basically the Terraform architecture. And this is where the Terraform workflow is. So Terraform is an IAC tool, and as part of the infrastructure as code process, you write your Terraform scripts, and they go through source code SEM. You can they go through the regular PR process. The changes are merged. You can do a diff. So you create the .tf files, uh, and you use VSTS or GitHub or any of your source control management tools to manage the source code, and it runs through the Terraform process of validating it, planning for it, and applying it. And that's how you build new infrastructure. So it's not just the code that you write that gets deployed onto an infrastructure, but right now, even the infrastructure components go through a source code management, go through a source control management, go through a review process, go through a PR process, and it becomes part of your life cycle in terms of deploying code. So you can deploy infrastructure similar to how you deploy your code. For example, if you want to deploy a virtual network, it's a click of a button to run through an Azure pipeline to deploy a virtual network. You want to stand up a whole development environment, or you want to stand up a whole production environment. It runs through the whole process similar to how your code goes through. Um, and that forms part of a larger DevOps process wherein your Terraform scripts are integrated much more into your overall lifecycle. Developers can create Terraform scripts as part of, for example, if you're standing up a API and the API requires an Azure App Service and requires a Cosmos DB backend or a SQL Server backend, you write a script which says, okay, as part of creating this API during its release phase, I want to make sure that there is a dependency on a Terraform script, and this Terraform script would go in and build your Azure App Service, would create an Azure API gateway, for example, would open up the necessary ports for you, create the necessary policies and security groups for you, and then it would also go ahead and create the backend services necessary. For example, it would create a Cosmos DB instance for you, create the necessary accounts in Cosmos DB, give them the necessary privileges, and stand up the whole thing. You can also use Terraform to sort of run Docker scripts. For example, let's assume you've got a Kubernetes infrastructure, and you want to stand up a Kubernetes infrastructure as part of your deployment script. It not only deploy a code, but you can also go ahead and create a Kubernetes infrastructure. Uh, and this is an iterative process. Terraform also understands your state. Terraform is very aware. It's not just a scripts, your Terraform scripts that you need to run through source control. Terraform is very aware. There is something called a Terraform state, and this Terraform state has deep knowledge of your current state infrastructure. It can refresh your current state, its understanding of your current state infrastructure, and then apply changes incrementally. For example, let's assume you already have an instance running in production and you're making a small change to it. Let's assume you're adding a new SQL Server instance. Your script need not create the complete infrastructure, but Terraform would know and understand that, okay, I've got all the other pieces of the infrastructure except for the SQL Server, and it would just go ahead and create that particular SQL Server instance. Or for example, let's assume your Terraform files are provisioning an account, or let's assume a SQL Server account. Your Terraform state would know that that SQL Server exists, and it just needs to provision an account to be provided to the application. So Terraform can understand what's your current state, and even the Terraform state files are source controlled. They do introduce a little bit of complexity in terms of managing the state files, but state files are again part of your SCM process and managed similar to any other source code artifacts that you have. Okay, before we jump into the actual Terraform language, any questions so far? Okay. James, you had something?
Can I just ask,
Yep.
the
Go ahead,
state
Ross.
that Terraform stores, that's different than the native state that's provided by, say, like CloudFormation, where it's got its state tracking to detect drift and to detect
Yes.
the current state. This
Yes,
is,
it's
it
very
doesn't use
different.
that.
No, it does not use that. Terraform manages its own state, and Terraform refreshes its own state. It actually creates a state file generally called .tf state. It does not use a native state that AWS or Azure or any of these native cloud providers do. Terraform has its own state management system.
Okay, and if that's managed in source control, then at deployment time, that state obviously needs to get updated. So does the Terraform runtime have permission to make a commit to the state change and apply that? How does that process work, where ensuring its state is up to date with actually what's deployed?
So there are two ways in which it does it. So as part of your build and release cycle, let's assume you are saying, hey, I've created a bunch of files which dictate my infrastructure, and then you run through a Terraform plan, and then you do a Terraform apply. So even before you apply your changes to your infrastructure, Terraform initially updates its state files and locks it, and then applies infrastructure changes, and then again commits those changes into the Terraform state file to say, yep, this is the current state of the infrastructure. And that's how it always makes sure that the state file is always updated and managed to be in sync with its existing state of the infrastructure. So if you look at the pipeline, even if there are multiple changes to the infrastructure, everything has to go through the state file, and the state file is always, you have to do a Terraform apply whenever you want to apply a change to any infrastructure component. And as part of Terraform apply, it always updates the state file.
Just a quick interrupt there, Pradeep, to answer that the concern about the source code. In the environments that we'll be deploying in Azure, the state file will not be stored in the repositories. It will be stored in Azure Blob Storage.
So the state file, thanks a lot for that, Paul. So the state file can either be stored locally or it could be stored remotely. During development process, during the initial development stages, you generally would store the state file locally. But the best practice is to store the state file on remote storage. You can store it either as an Azure blob, or if it is AWS, you can store it in AWS. Terraform itself has something called Terraform Cloud, which can be used to store, manage, and store state. So the state is always managed in a remote manner. I mean, it's stored in a remote stage provider. Does it answer your question, Ross?
Yeah, it does. Yeah, it was just that between where we have to do the PR for the desired end stage of what we want our infrastructure to look like versus the current state tracking. I was just, I thought the state was in source control, but if it's out with that, then that makes sense. So perfect. Thank you.
And even though the state file exists and the state file is available for you all to see, it's stored with an extension .tf state. It's not something that you mess with. It's something that you do not go ahead and change. The Terraform process changes and manages its state file for you. Okay, so moving on. Terraform is a concept of a provider, as I initially talked about. The provider basically talks to the backend API and performs necessary instructions to stand up infrastructure. And there are different, on the screen, I've shown examples of 3 different providers, which is an Azure RM provider, an AWS provider, and a GitHub provider. There are a lot more providers than these. The providers also manage credentials, and they know and understand how to connect to the backend APIs to perform the necessary infrastructure changes. You can also use multiple providers. So for example, I can let's assume you're working on a multi-cloud environment, multi-cloud as well as a hybrid cloud environment, where you're making changes across maybe AWS, GCP, and Azure. You can have one single Terraform project which can work across all 3 of these cloud providers. Let's assume, for an example, you're standing up an EC2 instance on AWS, and you're using GCP for running some machine learning algorithms. Maybe you could have a single Terraform project which can manage to stand up infrastructure across both these providers. So Terraform projects do support multiple providers. I've seen Terraform projects wherein we've had it work across GitHub as a provider, VSTS as a provider, AWS and Azure running concurrently together, and standing up infrastructure across all these various providers. So Terraform providers do support multiple backend environments. The way you initialize providers is by using Terraform init. I've put in a screenshot, and there is various versions of these providers. There are generally upgrades to these providers, and you can pin specific versions, or you can say, I would like to use the latest version. And Terraform init is what's used to initialize these providers. Terraform, the other important concept of Terraform is resources. The resource block generally denotes the resource that you're trying to stand up within Terraform. A resource could be any infrastructure component that is being provided by the backend provider. For example, over here, there's a virtual network VNet being provided by Azure, or a VPC being provided by AWS, an EC2 instance, an Azure App Service. All these are resources. For example, on GitHub, it could be a repository which is provided by GitHub, or on let's assume on Datadog, there are various other repositories or resources that Datadog provides. So those are all resources that you can stand up using Terraform. Resources have standard properties, for example, names and tags. Resources have also got specific properties. For example, VPC on Azure, on AWS has CIDR block as a specific property. A VNet on Azure has address spaces. Subnets have address prefixes. So there are specific properties for specific resources. But generally, each resource has name, location, and ID as standard properties. We will look at these as we go through code. Um, Terraform has also got a concept of data. Data sources are a means for you to query the provider. For example, a primary example is, for example, if you want to query AWS to figure out what are all the various Amazon machine instances that AWS provides, you can use a data block to query Amazon about the various AMI IDs that you can provision from AWS. Another example of using a data block is, for example, let's assume you have provisioned a bunch of virtual machines and you want to enumerate through all the virtual machines you have provisioned within a particular subnet. You can use a data block to say, hey, can you give me a list of all the virtual machines that are provisioned within a subnet? Or another example could be provisioning service accounts. Let's assume you've provisioned a bunch of service accounts and you would like to enumerate through those service accounts. You can use a data block provider to say, can you list out all the service accounts that I've created within this particular Azure AD service. So it's basically used to query the backend provider for information. So those are the three or four primary blocks within Terraform, which are critical to get started off on Terraform. Again, I'm trying to make it as simple as possible because this is a 100 series wherein we're just trying to get started on this. From a Terraform workflow perspective, the general workflow of Terraform, as you would run a Terraform plan and it outputs what are the changes to the infrastructure that that particular Terraform script would result into. And based on your acceptance of whether you're okay to apply those changes, it would then go ahead and execute a Terraform apply. And that would result in that particular infrastructure change being applied to your environment. And if you want to destroy whatever changes you have created, you can just destroy or roll back that exact change. And that's one of the best things about Terraform. Let's assume you went ahead and executed a change wherein you added a bunch of resources, but realized that those resources are not exactly what you needed. You can always run a Terraform destroy, which would look at your state file and then destroy exactly those changes that you recently made. And this is a pretty simple workflow. Terraform also provides you the ability to validate and make sure that your changes, your scripts are correct. Terraform also allows you to visualize changes as a graph. We will go through that when we run through code. So this is an output of a Terraform plan, or rather Terraform validate, which validates your Terraform scripts to make sure that there are no errors. I'm just ran through a Terraform validate with a few mistakes, and Terraform was able to pick it up quickly. When Terraform runs through a plan, this is a plan that it outputs. I put up a small screenshot of a larger plan. The way plan works, it shows the changes that it's making by a green plus sign, and it shows the infrastructure components that might be removed with a red minus sign. So that you can it can visualize the changes that are being made to the infrastructure. And based on your acceptance, it would then go ahead and apply those changes. And that's what I'm showing over here. Terraform basically checks with you if you want to apply these actions and goes ahead and creates the necessary infrastructure components for you. And if based on the previous changes that I made, basically I was running through a Terraform apply on Azure. It goes ahead and creates necessary Azure resources based on the scripts that I ran previously. We will be running through this as, in the code demo. Terraform destroy can then be used to rollback changes that you made to the infrastructure. Over here, I'm showing an example of executing Terraform destroy, which would then use your current state to say, okay, what is the infrastructure components that it needs to roll back, and you would then go ahead and destroy the infrastructure components that were created. So in this example, previously I'd created these components on Azure, and let's assume I'm finished using it and I'd created these temporarily. I can go ahead and say, yep, I no longer need these infrastructure components. People have used Azure previously know how hard it is to sort of remember exactly what were the components that you created and sort of roll back those changes. Terraform makes it pretty easy. It's a single command to say, yep, I made these changes. Now please go ahead and roll back all those changes. Terraform refreshes its state and we would go ahead and completely roll back all those changes that we had previously rolled through. And this is just a screenshot of Terraform going ahead and rolling back those changes and completely making sure that those components do not exist in Azure anymore. So with this, sort of done with running through a PowerPoint. It's not fun running through a PowerPoint. The idea was to basically run through code. Any questions so far?
Sorry, I have another one. Does it support
ahead,
drift?
Allow questions.
Does it support drift detection? So say some crazy person
Yes.
goes in and manually modifies the resources in the portal. Can it detect the changes are different from what it thinks are there based on its state file?
So Terraform can indicate that your state file has changed. When it tries to refresh your state file, it can definitely indicate that there has been a drift from the last known configuration, and you would be able to do a diff of what's the difference from your known configuration to the drift that's occurred because of manual changes. So Terraform can actually indicate what's the drift that's occurred because its state file knows what is the last configuration that it was aware of, and the next time you run and apply, it would refresh current state, and it would know that the state has changed, and it would be able to indicate what that change was.
Perfect. And does it also support blue-green deployment? So say you've got a resource that you want to update, that's maybe you don't want any downtime, so you want to deploy something side by side, migrate things over to the new resource, then tear down the old one. Does it support that?
It depends on how you set up Terraform. So generally, as part of blue-green deployment, you would set up let's say multiple environments, or you would set up an ability to say, hey, I mean, this is my blue workspace and this is my green workspace, and you would run it in such a way that it can run things in parallel and switch over. So it's not more of a Terraform concern. It's more of a design concern in how you design your workspace to let you run through blue-green deployments. Let's assume you're using Kubernetes or Docker. It would then be a concept of how you design your Terraform scripts to allow you to roll in changes and switch, let's assume, your network gateway to allow specific traffic onto specific pods. So it's more of a design concern rather than Terraform allows you to do that, but it's more of a design concern, I would say. Make sense?
Perfect. Yeah, thank you.
Cool. Okay. So let's try to run through code. Just a sec while I. Just give me a minute while I start. I'm just starting up Visual Studio, guys. Just give me a minute. Okay, so to start off on Terraform, I've created what I've done is, because this demo is being recorded, I've already, the idea is to run through a piece of code which will stand up a virtual machine on Azure. One of the first things that we need to do is provide credentials for the Azure provider. Since this session is being recorded, I've already done an AZ login onto my session just now, so that the necessary environment variables, which would allow Terraform to connect to Azure, has already been set. So let me go in and say main.tf. One of the first things that we need to do is to create a provider. I'm creating an Azure RM provider, which will allow me to connect to Azure. And as I said, I've already authenticated to my Azure instance using AZ login. And as part of AZ login, it sets in the necessary environment variables necessary for the Azure provider to connect to my Azure instance. Let me also open up my Azure instance. So on my Azure instance now, if I see all the resources that I have, I do not have any resources except for my default Cloud Shell storage, which is used for the Azure cloud-based CLI. Uh, so as I said, what we would like to do is to go ahead and create a virtual machine on Azure. And to create a virtual machine, there are a few other components that we would need. We would need to create a resource group for the virtual machine to live in. I would like to create a virtual network and a subnet within which the virtual machine can reside. I would also need to create a public IP address, which I can then associate with a network interface card. And then I would need to associate that particular network interface card with the virtual machine. So there are at least 5 or 6 components needed before I can stand up a virtual machine on Azure. So let's try and declare what we need to do to create a virtual machine on Azure. So the initial thing that I need to do is to say, hey, I mean, this is my Azure provider, and I'm using version is equal to 2.8.0. I'm not using any features. Then the first thing I need to create is to create a resource group. What I'll do before this is, because I'll need IntelliSense, I will go ahead and do a Terraform init, which will then indicate that this particular directory is being used for Terraform. And what Terraform init does is it initializes the backend. It knows that I'm using an Azure RM provider. So it basically downloads the Azure RM provider. And you can see over here that it's downloading the version that I indicated. Over here, I'm basically saying that I need the 2.8.0 version. I'm pinning it to a specific version. So it downloaded the 2.8.0 version of the provider. And to create the resource group, I'll say resource Azure RM underscore. I'm not sure why I'm creating a resource group, and I'll call the resource group 1. Generally, sorry, go ahead.
Is it the missing comma after your version, mucking up the IntelliSense?
No, it should be fine. Not sure why it's saying that. I've had issues with the IntelliSense with Terraform, primarily with the 2.8 version. I'm not sure. Let's give it a shot, and let's see if what I'll do is I'll do something. I'll just run Azure Terraform validate. Not sure. Come on.
Pradeep, is the equal sign not on the wrong side of the block brackets there?
You need both. I think you need it before and after.
Oh, yep. That's a mistake. Thanks for that, Leon and James. Cool. Okay, so let's create Azure RM underscore resource group. Let's say and I'm just giving some name. Again, I'm trying to keep this simple. I'm not going through other things like variables and outputs. So I'm making it as simple as possible because we are just an hour to run this thing through, and I'm trying to make sure that we're just going through the bare bones information needed to ensure that we can get through this demo. So basically over here, I've created a resource group, and the next thing that I need to create is create a virtual network. So a VNet in Azure is needed for us to be able to create the necessary networking infrastructure to stand up the virtual machine. So to create a virtual network, resource Azure RM underscore network called VNet. Name is equal to, and the IntelliSense also allows me to figure out what are the arguments which are required and what's missing as part of this block. I know that I need to give it a name, a location. Australia East, the resource group name is, and this is where the way you use the variable that you previously created. So if you look at this, this is a variable that I've created pointing to the Azure resource group with this particular name and location, and that's what I'm using over here. And this is how Terraform basically builds a graph. So Terraform now knows that to create this virtual network, it needs to take a dependency. It's dependent on this particular resource group that you have created previously. So this is, and I need to give it address underscore prefixes. I need to give it the address space. I will give it it's a list, so I'll give it a 10.0.0.0/16. I think this should be enough to create a virtual network. Yep. So then I'll create a subnet. So resource creating a subnet called public subnet. Again, the same things hold good over here. It requires the regular properties of name and resource group. Then the virtual network to which this subnet is associated, that would be and then the address prefixes associated with this. It's a list. Before, let's say, okay, so this creates the necessary subnet for us. Now let's create the network interface necessary. Now, before the network interface, I need the IP address. This is a public IP address needed. So the same thing here, name. This is the public IP for the virtual machine. It exists in the resource group. And what are the properties does this require? Yep, this and allocation method. So basically, I'm getting a dynamically allocated IP rather than a statically allocated IP address. This would create the necessary IP. Now this IP address has to be associated with the network card. So create. So I need to create a NIC over here. So I say resource network interface devNIC. And this is the actual network interface card for the VM. So this particular network interface card has to be associated with the public IP and the virtual machine that we would be creating. Again, you can create multiple network interface cards for one virtual machine, but I'm creating only one over here. So these are the normal properties. Then I need the IP configuration for this particular network card. And over here, NIC1. Subnet ID is the Azure RM subnet dot public subnet dot ID. The private IP address as dynamic. The public address RM public IP dot. So this creates network interface card. So we have most of the necessary components for creating the virtual machine. We have the virtual network, we have the subnet, we have an IP address, we have a network interface card. Now we need to actually create the VM. I'm going to create a Windows Server VM. Any questions so far?
I have a quick question, Pradeep.
Yeah, Ankit.
Like, see, I understand what we're doing with Terraform, but the question which I have is like, why would I use a Terraform script in place of, let's say, Azure CLI directly? Because what you mentioned is that Azure CLI is probably being used by the Terraform script to call those things, anyways. So, what's the advantage of probably using something like an ARM? Like, what's the advantage of using Terraform over an ARM?
So you could use ARM templates. ARM templates works perfectly fine. ARM templates are basically JSON based. But if you look at the programming constructs between an ARM template and what we're trying to do with Terraform, if I had to create an ARM template for something like this, I think somebody like Heinrich who's previously created an ARM template can vouch for this. An ARM template can get pretty much verbose. A lot of this is extremely verbose on an ARM template, and an ARM template is primarily written in JSON. And again, ARM does not provide you the ability to do the sort of life cycle that we can do with Terraform, right? In ARM, we don't have an option to sort of plan and apply. You cannot say, what are the changes will my ARM template result in? Am I okay with these changes? And then apply those changes. And again, once you go down the ARM template rule, you're basically stuck with one particular provider, which is Azure, right? And if you want to mix and match, it becomes pretty hard. That's the second part of it.
Okay, yeah. I think one of the things which Paul said in the chat is that it's not infrastructure as a code; it is infrastructure as a data, which I think makes sense. Yeah. Yeah. Thanks.
I've not been looking at chat. Okay.
I have one for you as well as one thing with the Amazon AWS code build was that it was slightly behind the cloud formation. How far behind is Terraform from the providers?
there is definitely a lag between when new functionality is released and when that same functionality is onboarded onto Terraform. But it's not a lot because there has been pretty good uptake on Terraform. So the cloud providers do know that they need to upgrade their Terraform providers to the latest version. For example, on Azure, the version that I'm using here is 2.8.0. I know that it moved from version 2 to 2.8.0 over a matter of 6 to 7 months. So I would say the progress, there is not too much of a lag between when new features are released to when new features are onboarded onto the provider. But it also depends on how you can upgrade your scripts, because let's assume you start off, a lot of folks have started off on version 2 of the Azure RM provider. And let's assume you move forward based on that. You also have an option either to pin it to that specific version, or you can say, are the changes in the newer provider version backwards compatible? So there is also the concept of having to upgrade your code to the latest providers too. So there is some amount of complexity around there. That's it.
Cool. Thanks.
Okay. So let's create the Windows Server VM. What we can do is we can create Windows Server. So Azure RM underscore Windows machine VM. Okay, that's because my name. So we'll provision standard A1, which is a small instance. I'll also take a shortcut in hard coding the admin password and admin username directly over here. In reality, you do not hard code these in your code, rather you either auto generate something.
No.
I knew that was coming from you, Paul. Let's.
Oh, at least it's not password.
I think it should be
Okay.
proderp.
Okay. Then we also need the resource group name over here.
Can I just ask, are you running the plugin that comes with Visual Studio Code that helps with all this, or is this just?
Yep, I've got the Terraform plugin over here.
Cool.
There are actually a couple of different Terraform plugins for VS Code as well, and some of them support the latest version better than others. I can grab details if you like.
Yes, Paul, that'll be great. devnik.id. Okay, and that's the network interface card. So we basically specify the network interface ID over here. The other thing we need to specify is the disk. To specify the disk, I will use a standard LRS. I think I need to do caching. And I need to give the image that we would be using. And maybe Paul would not be happy with this, but we are using a Windows Server.
Hey, bro, it's your money.
Microsoft Windows Server. the offer would be Windows Server, the SKU, data center, version, and I think that is all the information that you need to create. Yep, let's run Terraform. We have 2 minutes to go. Validate. Line 47. Private IP address allocation. Yep. Okay. That's interesting.
Is there an equals missing for the object? So IP configuration equals object. Maybe?
Just a sec. Private IP address. Okay. Now the issue is here. Yep. So now is the interesting part when we run a Terraform plan. You can see that it created a state file over here. So right now it's generating this particular state file. And once it refreshes the state and identifies the changes that it needs to do, we should be able to open up the state file and see what's inside the state file. But ideally, you do not mess around with the state file. Once the state file is corrupted, it can cause a massive amount of pain. Come on. So there we go. So basically what Terraform said as it would need to basically create every single thing in this because none of these things exist currently. So it has gone and refreshed the state and figured out that it needs to create all of the components that we have mentioned as part of the script. So there are 6 components that it needs to create. We can actually even generate a graph, Terraform graph, pipe it to dot minus tsvg resource graph dot svg. I'm trying to create a dot file. Come on. Okay, it's unable to create a dot file. I will now go ahead and say Terraform apply, which should then apply these changes, and I'll try and generate the dot file again. So Terraform plan right now knows what it has to create. It has created this particular state file. That says state file is currently locked because Terraform apply has locked the state file to see what changes it should apply. Okay, Terraform apply says, okay, I need to go create all these resources. Can I go ahead and create? I can review it and say yes. And what I can do is I can go check over here. Being created. So it's initially creating the resource group. So basically Terraform has created a graph, and based on the graph, it realizes it has to create the resource group initially. So it's creating the resource group. It's creating the virtual network. It's created the public subnet. It's created the network interface card, and right now it's creating the virtual machine. Yep, there it is. The virtual machine would take a bit more time to create, but you can see that it's already created the virtual network over here in Azure with the necessary properties that we had already set. It has created the network interface card that we specified with the IP configuration with the public IP address that we wanted. The IP address is dynamic, and that's being provisioned from over here. So it's basically even created the resource group that we needed. If you see, all of these things would be in the resource group called finance team resource group, which we created as part of the script. And if you go to the resource group, you can actually see that the virtual machine is already being provisioned. So you can see over here right now, we have basically we created a resource group called finance team resource group. We provisioned a virtual VNet virtual network. We provisioned a subnet within it. We provisioned a network interface card and a public IP and a virtual machine. While the virtual machine is still being provisioned, we can see that the disk has been provisioned. The virtual machine is right now being provisioned, and basically this is how you use Terraform to stand up infrastructure. We'll just wait for it to create this. Any other questions so far? I realize we're running a bit over time.
I have another quick question. I know
Yeah.
we've not touched on inputs and outputs on stacks, but seeing the graph command there, I was wondering, does it provide any ability to show dependencies between stacks with the graph functionality?
Yes, it does. After this, I'll try and generate the graph again. So basically, the way you define stacks is a bit different. So depends on what is your definition of a stack. For me, um, uh, I can consider, if I consider this as a stack and say, okay, I've created a stack which stands up a virtual machine, or for example, let's assume rather than just standing up a single virtual machine, I'm standing up a virtual machine scale set with maybe multiple virtual machines within this, and also onboarding applications onto those virtual machines, or using provisioners to deploy specific things on the virtual machine, then it's a complete stack. In which case, Terraform does show a relationship between all the various components of the stack. And that's how it builds a whole declarative notion of infrastructure. It figures out what are the various relationships between the various components that form a part of this stack, and then says, okay, now to stand up this virtual machine, I need to create a virtual network, and it requires a subnet, it requires an IP address, and it builds a whole relationship and then starts creating them based on how it defines those relationships. And that's the reason, if you really look at it, it initially created the I can move things in the script file however I want. Let's assume I create in the script file, I say I need a virtual machine right at the top, but then I say create the resource group right at the bottom. The order in the script file doesn't matter because Terraform can actively identify what's the relationship, and that's the reason why it initially creates a resource group, because based on the graph that Terraform created, it knows the resource group needs to be created first, and it also knows that the network interface card, the IP address, and the subnet needs to be created even before it stands up the virtual machine. So it builds a complete graph based on that. Okay, does it answer your question, Ross?
Well, that's within a stack. So I'm not sure on the terminology in Terraform, but I'm used to doing CloudFormation and Pulumi, which have the concept of, your grouping of resources within a stack, and then say when it creates something that you don't know it, at the time that you write it, such as an internal identifier of a resource it creates, and you want to expose that so that another stack you can create can reference that.
Yes.
I was just wondering if that kind of
Yes.
graphing of
Okay, that
exports or outputs is available.
Yeah, so that makes sense. So let's assume you have a stack which creates a couple of databases, and now you need to be able to export the databases, the connection information to the databases, and the let's assume the accounts that you have created to connect to those databases, so that it can be subsequently used by another stack, which is the application stack. Yes, that's definitely possible. You have a concept of inputs and outputs. That's maybe something that we can do in a subsequent session. You have a concept of inputs and outputs into these scripts, wherein, for example, rather than manually configuring the user ID and password for the VM, I can use that as an input, and it can actually create an output, which is the IP address of the virtual machine, as an example, to be used by subsequent stack. So that's possible.
Keep in mind also that with most of what we're going to be doing in Azure, the provider that we'll be actually using for the majority of the time will be the Kubernetes provider. And you hopefully won't have to deal with VMs and IP addresses and rubbish like that.
Perfect. Yep. Cool. Thank you.
Okay, I think I've been able to generate a graph. So I did generate a graph now, and let's say I want to open this graph. Come on, reveal in File Explorer. So this is the graph that. So yep, Ross, this is the answer for it. So basically, this is a graph that Terraform created based on the script that we generated right now. So it basically knows that at the root of the infrastructure that we created right now, at the root is a provider, which is Azure RM. Then then it figures out that the primary dependency is on creating the resource group, and then the virtual network and the IP address. And the other part of doing this dependency graph is that Terraform can also provision resources parallelly. So for example, over here, Terraform knows that it can provision the public IP address and the virtual network and the VNet in parallel. So it would go ahead and provision both these things in parallel, but it knows that the subnet cannot be provisioned without the virtual network VNet being created prior to that. So it would not provision the subnet in parallel with the VNet. It will always make sure that the VNet has been created and then provision the subnet. And this is a graph that Terraform creates, and this is how declaratively it understands what needs to be created for us to generate a virtual machine. If you really look at this graph, the ultimate output of this graph is a creation of this virtual machine. Okay, so Terraform has been able to generate the necessary infrastructure that we needed. Now it's up to the developer to then run his pipelines to deploy code or run any provisioners required into this virtual machine. And let's assume we want to destroy this. What we need to do right now is Terraform destroy, and Terraform would now figure out, okay, what does it take to destroy all resources that we created, and run through a similar process of destroying resources. I'll just wait for this to go in. So I know we've already run 11 minutes longer than what we expected. So this is the Terraform destroy output, similar to how we did during Terraform apply. During Terraform apply, it basically said what are all the components that it would be generating. As part of Terraform destroy, it's outputting all the components that it would need to destroy. And I say yes, and it would go in and destroy all the components that we created just now.
Yep. So Pradeep, needless to say that the Terraform script, that when it will be destroying, it actually would be able to understand which resource group goes first and second, right? Essentially, it would be able to
Similarly,
create
to generate a graph. Yeah, it similarly uses the same graph that I showed right now to say what is the order in which it should be destroying it.
Got it. Yeah.
Okay, I think this would take some time. Any other questions in the meanwhile?
Just one for the subscription side of it. I remember you mentioned something about the providers and it knowing all of that. So like, does it have a way of like, if you have multiple subscriptions and stuff, how does it manage that? Is that all just settings for the provider?
So for each provider, so you can either pass in the necessary parameters to connect to Azure, to the Azure provider. So for example, if you take a look at the Azure provider, it has other properties which allow you to specify the subscription ID, the tenant ID, and a lot of other information which would allow it to connect to Azure. But since it's not a good idea to store that information as part of your source, you generally store it in the necessary environment variables. For example, the Azure RM provider looks at a bunch of environment variables starting with Azure ARM underscore subscription ID for the subscription ID. So you can run a script which will populate the necessary environment variables so that the provider would know and understand how to use those environment variables to connect to the necessary backend APIs. So AWS, the AWS provider also has a bunch of parameters that it uses to connect to AWS. And as long as the necessary environment variables are hydrated, they can use those environment variables to connect to the backend.
Cool.
Okay, so that's what I had for this very, very quick and short overview of Terraform. Again, this is not an ideal demo. The idea was to just make sure that we can have something quick and dirty to just say, how do you use Terraform and how do you stand up infrastructure using Terraform? There are no best practices in this session that I did. There are no good practices in this session that I did. A lot of things that I did in this session are not healthy for production or for any sort of use. It was just as a means to as a shortcut to say how do we get started on Terraform. So do not try a lot of these things if you're trying it in real life on any sort of environment, even if it is a testing environment. That's a huge disclaimer. So that's what I had for this session. Any other questions before we end the session? Okay, and one question from mine. Would you guys want to run through a series on IAC, Terraform, maybe with Paul, Heisey, and the others also, or are you guys interested in running through subsequent sessions on further deep diving into Terraform, or would you want to see other sessions?
See, I think one thing which I would be definitely interested in is how we are using it in on our side, on the side of you, how we are using Terraform script to create Azure Resource Manager in Azure DevOps and everything else. I think that would be a great learning experience.
Sure, definitely. Those would be forthcoming. Okay, cool. Thanks a lot for your time, guys. I mean, we ran over 15 minutes, but I hope it's okay. Thanks for your time, and we will again catch up for next week for the next technical round back. Thanks.
Thanks, Pradeep.
Thanks, Pradeep.
Good idea.
Okay.